Welcome back, students. First, we will recap of our previous part. Okay. First, we will do recap of our previous part. In the previous part, we see industrial uses of acids. In that, uses of hydrochloric acid we see it is used for the cleaning of metallic items in dyestuffs in printing industries. Okay, it is used for the cleaning of metallic items in dyestuffs in printing industry. Second, we see regarding about sulfuric acid, it is used in the manufacturing of fertilizers, chemicals, paints, dyes, plastics, synthetic fibers, explosives, and car batteries. It is known as king of chemical. It is known as king of chemical. Third uses we see about nitric acid HNO3. It is used for manufacturing of fertilizers, dyes, plastic, and drugs. Okay, for the drugs also it is used. So these are the uses of nitric acid. Acetic acid CH3COH, which is called vinegar. Okay, used as vinegar in cooking and food preservations. It is used for the preservation of the food. After that, we see about bases, introduction of bases. We see definition of bases. Bases are substance which have written test and so fit to touch, and it turns red litmus paper to the blue litmus paper. Okay. After that, we see the examples of bases. Some examples: calcium hydroxide, potassium hydroxide, magnesium hydroxide, sodium hydroxide. These are the examples of bases. Okay. After that, we see physical properties of bases. In that, first we see test. We know the taste of bases, that is bittering test. We know feeling of touch, that is slippery touch, that is so fit to touch. Effect of indicators we see with the help of indicators also. Okay. With the help of indicators we see by doing activity also. Okay. So in basic solution, turn the color of red litmus to the blue litmus paper. We seen yesterday only. Methyl orange changes its color in basic medium, orange to yellow color. Phenolphthalein indicator, colorless to it changes into the pink color. And last we see the electrical conductivity of the bases. Okay, so basic solution conduct electricity because it produces ions. That's why it conducts electricity. Up to this we see in the previous part. Okay, so today we will learn about now we are going to learn about chemical properties of bases. So one by one we will see the chemical properties of bases. In that first one, when bases reacts with metal, what happens? We have to see. Already we seen about the acids. What happens with the acids? Whenever the acid react with metals, at that time it forms salt plus hydrogen gas. I hope that you know already general reaction of acid when acid reacts with base. General reaction is acid plus metal, it gives metal salt plus hydrogen gas. And how to identify this hydrogen gas? With the help of activity we seen also. Okay, it gives pop sound. So same reaction is there for the bases also. Whenever the bases react with metals, at that time all bases are not going to be react with the all metals are not going to be react with the metals. There are some heavy metals are there that only are reacting with the bases. And the general reaction for this, whenever base react with metals, at that time base react with metal, at that time it will form metal salt plus hydrogen gas. Same general reaction for acid and bases. Whenever acid or base react with metal, at that time it form base salt or acid salt plus hydrogen gas. Okay, they will form respective salts. I hope that you understood. I am taking only one example. So we have example sodium hydroxide. It is a base. Sodium hydroxide is what? Base, and it's reacting with metal. It's reacting with metal, and we have metal, that is zinc. So base sodium hydroxide reacting with metal zinc. At that time it forms sodium zincate, Na2ZnO2. Okay, it is called sodium zincate, and common product which we are getting, that is hydrogen gas. That is hydrogen gas. Okay, so this is our first chemical reaction. That is bases react with metal. At that time it will form base salt plus hydrogen gas. Clear? Okay. Now, second chemical reaction, second chemical properties of bases. When bases react with acids, we know that already. Why I am saying this? We know that already because we see in the reaction of acid and base. At that time, what happens? We know that it is called neutralization reaction. It is called neutralization reaction, and in that reaction we are getting product. Okay, salt plus water. So we know very well, whenever acid reacts with base, at that time it forms salt plus water. Same reaction. Okay. So general reaction for this, base react with acid, at that time it gives salt plus water. Okay. So base we are having sodium hydroxide. It is reacting with HCl. It gives sodium chloride and water. Okay, I am taking just one example. You can take KOH also. Okay, magnesium hydroxide, potassium hydroxide, sodium hydroxide. These are the common bases which we are using in the commonly we are using. Okay, so I am taking only sodium hydroxide reacting with HCl. It is acid. It is base. Whenever acid reacts with base, at that time, or base react with acid, at that time it forms salt plus water. It forms salt plus water. Okay. So sodium hydroxide reacts with HCl. At that time it will form NaCl, sodium chloride, and H2O. Okay. Clear? I hope that is clear. Now, third chemical reaction. Chemical properties of bases, that is whenever bases react with non-metallic metal oxides. See, metal oxides are basic in nature, but in case of non-metal oxides, these are acidic in nature. These are acidic in nature. Okay. Whenever metal oxides are there, these are basic in nature. Non-metal oxides are acidic in nature. Pay your attention what I am saying. Non-metal oxides are acidic in nature and metal oxides are basic in nature. So we are reacting non-metal oxides. These are generally they are acidic in nature. So it means that we are reacting acid plus base. Acid plus base. It means that what we are doing, neutralization reaction. Same reaction, and what will be the product of neutralization reaction? You know that very well, and the product is salt plus water. Okay, so we will see when bases react with non-metallic oxide such as carbon dioxide to give salt and water. I took few examples of non-metal oxides. Okay, so example, that is sodium hydroxide reacting with non-metal oxides, okay, which behaves as acid. It gives salt plus water. It means this reaction is same as it is reaction of base with acid or acid with base. Okay, so this reaction is similar to the reaction between base and acid. This reaction is similar to the base and acid, and thus we may conclude that non-metallic oxides are acidic in nature. So we may conclude that Non-metallic oxides are acidic in nature. So what will be the product of this reaction? Salt plus water. Okay. First reaction we see, reaction of bases with metals. At that time it forms salts. Okay. Metal salt plus hydrogen gas. When base react with acid, it is a neutralization reaction. It gives salt plus water. Whenever non-metal oxides are reacting with bases, it gives same reaction, that is salt plus water. Okay, until now it's clear. Now the fourth chemical property of bases, which is very important, reaction of bases with heavy metal salts. What I am saying? Reaction of bases with heavy metal salts. Solution of salts of heavy metals like copper. Which are the heavy metals? Solution, that is copper, iron and zinc. Copper, iron and zinc when added to aqueous solution of bases. When added to aqueous solution of bases, we will see with the help of activity also this reaction. Okay. So added to aqueous solution of bases, they form precipitate, PPT. Okay, it means precipitate of solution, that is metallic hydroxide. It is metallic hydroxide. So we are having example, zinc sulfate react with base. At that time it will form, that is metallic hydroxide. It means zinc hydroxide and metal salt, that is sodium sulfate. Sodium sulfate hydroxide, when is forming sodium hydroxide and another one is forming salt. Okay, so it gives, whenever heavy metals added to the aqueous solution of bases, at that time it gives PPT of metallic hydroxide. Keep in your mind, whenever we are reacting heavy metals with aqueous solution of bases, they forms metallic hydroxide. They forms metallic hydroxide. We having well-known example, zinc sulfate reacts with sodium hydroxide. It gives zinc hydroxide, white PPT. Okay, it gives which PPT? White PPT plus sodium sulfate. With the help of activity, we will see this reaction. So already I made zinc sulfate solution. Okay, now only I made zinc sulfate solution. It contains zinc sulfate, aqueous solution of zinc sulfate, and we are having aqueous solution of, that is NaOH. Okay, it is NaOH, sodium hydroxide. It is sodium hydroxide, and we know that whenever this zinc sulfate, okay, zinc sulfates, heavy metals solution reacts with, at that time it form hydroxide. Which hydroxide? Metallic hydroxide. And what we are using? Zinc sulfate solution. So it will form zinc hydroxide. Okay, if we are using copper sulfate, then it will form copper hydroxide. Okay. So this is your base. This is sodium hydroxide. When we are reacting aqueous solution of base with the heavy metal, okay, with the heavy metal salts, at that time it form respective metallic hydroxide. Okay, so and it gives PPT. It means you see it. Now it is clear solution. Okay, so when we are adding this metallic salt into the base, at that time it will form precipitate. See, it forms an precipitate. I hope that you are able to see it. So this is your zinc hydroxide. Okay, I hope today you understood about previous part of revision of previous part, and simultaneously you understood about chemical properties of bases. In that we see reaction of bases with metals. We know the general reaction of when bases react with metals, at that time it gives metal salt plus hydrogen gas. Reaction of bases with acid, it gives salt plus water. After that, reaction of non-metallic oxide, same reaction gives, that is metal salt plus water. And last reaction we see reaction of bases with heavy metal salt. In that we see whenever heavy metals, what are, which are the heavy metals? Copper, iron and zinc. These are the heavy metal salts. Okay, these are heavy metals, and these heavy metal salts, when we are reacting with aqueous solution of bases, at that time it forms PPT. You seen it. Okay, this is PPT. Okay, so today we see that much part. With the help of AV, we will see about uses of bases and pH scale. Okay, with the help of AV only we are going to see that uses of bases. After that we will see pH scale. Okay, that is Pauling pH scale. I hope that you understood. Thank you. Have a nice day. Stay safe, stay home. Thank you.
Uses of acids and bases. Acids are used in the laboratory for the identification and preparation of many acids, radicals and compounds. Bases are widely used in the preparation of chemical fertilizers. Some important uses of acids. Sulfuric acid, manufacture of fertilizers, chemicals, explosives, paints, dyes and drugs. Nitric acid, used in manufacture of fertilizers, chemicals, explosive, paints, dyes and drugs. Hydrochloric acid, used in tanning and printing industry. Citric acid, in medicine, source of vitamin C, flavoring drinks. Boric acid, used as an eye wash, preservation of grains. Acetic acid, flavoring food, food preservation. Benzoic acid, food preservation. Carbonic acid, lends fizz to aerated drinks. Oxalic acid, in ink stain removers. Tartaric acid, constituent of baking powder, reacts with sodium bicarbonate to release carbon dioxide, which makes the dough light and spongy. Some important uses of bases. Sodium hydroxide, manufacture of soap. Calcium hydroxide, manufacture of bleaching powder, mortar. Softening of hard water, neutralizing acid in the soil and in water supplies. Magnesium hydroxide, as an antacid to neutralize acidity caused by hydrochloric acid in the stomach. Aluminium hydroxide, foaming agent in fire extinguishers. Ammonium hydroxide, used to remove grease stains from clothes. Potassium hydroxide, alkaline batteries.
Importance of pH. pH is the measure of H+ ions present in a solution, indicating the acidic or basic strength of the solution. The pH of a neutral solution is 7. Values less than 7 on the pH scale represent an acidic solution. Whereas, with the increase in the values from 7 to 14 on the pH scale, the basic strength of the solution increases. Our body works within the pH range of 7 to 7.8. pH of acid rain is 5.6. When the water from the acid rain flows into rivers, it lowers the pH of the river water, which causes lots of damage to the aquatic life. Plants also require a specific pH range for healthy growth. You know that our stomach produces hydrochloric acid, which means its pH is less than 7. Excess production of acid by the stomach causes pain and irritation. We usually take antacids to get rid of this pain. For example, magnesium hydroxide, that is MgOH2, is an antacid which neutralizes the excess acid. Also, after eating, the bacteria present in the mouth starts producing acid due to the degradation of sugar and food particles left over in the mouth. This reduces the pH of the mouth below 5.5, and the tooth enamel, which is made up of calcium phosphate, that is Ca3PO4(2), which is the hardest substance in the body, starts decaying. Therefore, it is advised to clean the mouth after eating food using some toothpaste. These toothpastes are generally basic in nature. When a bee stings someone, it leaves some acid which results in pain and irritation. Using mild base like baking soda can give some relief when applied over the affected area. Similarly, nettle leaves produce stinging sensation when contacted because they inject formic acid, that is HCOOH, which results in burning pain. Rubbing some leaves of dock plant over the affected area provides relief to the irritation.